Let's practice applying our understanding of percents and percent applications with these practice problems together. So in number one, we're going to go ahead and fill in this table with the missing values of each ratio. So we're making a bunch of different comparisons here based on some different values. So for percents, we're going to be going to per 100. With our decimals, it's always going to be per 1. And then our fractions are going to be a little different each time, and they're going to be per different amounts each time. So for number one, we have 36%. If we want to take this percentage and turn it into a decimal, then we're going to go ahead and divide it by 100. If we divide it by 100, we're going to take that decimal and essentially slide it 2 places to the left. So our decimal here per 1 is going to be 36 hundredths. That's the decimal. And then if you read this decimal as 36 hundredths based on the place value here, then we know it's going to be as a fraction 36 per 100. All right. So that's going to be the initial fraction. Then we're going to go ahead and see if we can simplify this. I think we can find a GCF of 4. So divide this by 4 and 4 to get our most simplified fraction here. So 36 divided by 4 will be 9, and 100 divided by 4 will be 25. All right, for this next one, we have a decimal to start with here. So we have 0.008. So we think about what this is. If we read this, it's going to be 8 thousandths, right? So we have 0.008 or 8 thousandths. If you want to go ahead and make this into a percentage, we have to essentially multiply this by 100 because that's per 100. So we're going to go ahead and slide this decimal twice to the right here. If we do that, it's going to end up being 0.8 or 8 tenths of a percent. All right, so it's less than 1% here. Next, if we go ahead and write the fraction, if we read this is 8 thousandths. So if we read that decimal correctly here, or more exactly, we're going to have this 8 over 1,000. And then we can go ahead and divide this by 8 and divide this by 8. That's going to be the greatest common factor of both numbers. And that's going to be 1 on top. And then 1,000 divided by 8 is going to be 125. So that's our most simplified fraction. For this third one, we have a mixed number. We have this 2 and 7/9. I'm going to recommend that you start off by turning this into an improper fraction. So 2 times 9 is going to be 18. 18 plus the 7 on top is going to be 25. So this is the same thing as 25/9. And so to get a decimal, you can do is you can essentially just take the 25 and you can divide that by the 9. So if you go ahead and do 25 divided by 9, feel free to use a calculator or do the long division, but 25 divided by 9, you're going to find is going to be 2.7 repeater. All right, so if this is going to be our decimal and we want to turn this into a percent, then we have to go ahead and just take this decimal and multiply it by 100, okay? So if we multiply it by 100, we're going to essentially move this decimal twice to the right. Now, typically, if we didn't have a repeater, we would have to add a 0 at the end, but here we're going to know it's going to be 277.7 repeater percent, okay? This would be the percent in this case. Looking at this next fraction, we have this 45 over 72. If you look at this fraction, notice that we could possibly simplify this. So think about what a GCF or greatest common factor would be here. I think we can divide these both by 9. So if you divide these both by 9, we're going to end up with 5 over 8 or 5/8. All right. If we want to turn this into a decimal, you might potentially have this memorized, or you might need to do long division here. So you can go ahead and do 5 divided by 8. If you do that, then this decimal is going to end up being 0.625 or 625 thousandths. So that's going to be our decimal, 0.625. And if you want to go to turn this into a percent, just like we did earlier, we're going to multiply this by 100 and essentially slide that decimal 2 places to the right to make it 100 times bigger. So this would end up being 62.5 or 62.5%. For this next one, this one's a little bit trickier because we have a fractional percent here, okay? So when we have this fractional percent, I think it's a good idea to turn the fraction part of it into a decimal. So we have this 5/6 here. So if you go ahead and take 5 divided by 6, go ahead and do that on the side of 5 divided by 6, just to figure out what that part's going to be. And you go ahead and divide those. You can use long division or a calculator. That's going to be 0.83 repeater. Right? So another way to write this percent is going to be 8.83 repeater percent. That's another way to write this. All right. Once you have that, then if you wanted to take that percentage and turn it into a decimal, since we have a decimal now, we can go ahead and essentially divide this by 100, right? When you want to turn a percent into a decimal, then divide it by 100. And if we do that, we would slide this twice to the left. If we do that, we're going to have to add a 0 in here, but the decimal version is going to be 0.0883, and that 3 is still going to repeat here. Now, in terms of the fraction, we want to keep in mind that what percent means. Remember, percent means per 100. So if we want to go ahead and write this, then this is going to be 8 and 5/6% is going to be 8 and 5/6 per 100. Okay, so that's going to be out of 100. And then if we take a look at 8 and 5/6 as an improper fraction, 8 times 6 is going to be 48, plus the 5 is going to be 53. So this is going to be 53 over 6. And then if you divide by 100, we can write that as divided by 100 over 1. Just keep in mind that over 100 means divide by 100. And then if we go ahead and turn this into a multiplication problem, this would be 53 over 6 multiplied by 1 over 100. And then when we multiply fractions, we just multiply across, but 53 times 1 is 53. And then 6 times 100 will be 600. So this would be our final fraction here. If you want to check that on a calculator, you can do 53 divided by 600, and you should get this decimal over here. And if you slide the decimal twice to the right, you'll get this percentage over here. For this last one, if you go ahead and read this decimal, this is 5 and 4/10. So as a mixed number, we would write 5 and 4/10 right away. And then you would ask yourself if you could simplify this, and it looks like we can divide these both by 2. So dividing these both by 2, we would get 5 and 2/5, and then we would be done. And then if we want to go ahead and turn this decimal into a percentage, how did we do that earlier? Well, turning all decimals into percentages, essentially we multiply the decimals by 100. And when you do that, you end up sliding that decimal twice to the right. So if we do that, then this percentage is going to be 540%. All right, cool. So these are going to be all the different versions of these fractions, decimals, and percents. Comparing them to some different values of percentages that are always per 100, decimals are always per 1, and fractions are going to be a little different each time. It could be a different denominator or out of a different number. All right, let's check out number 2. For number 2, we're going to take each of these scenarios, write a simplified fraction, a decimal, and a percent. Then we're going to go ahead and make sure we write these using exact values, so we're not going to round at all. So for A, we get 35 out of 40 points on a social studies quiz, so the original fraction would be 35 over 40. Then if we want to go ahead and simplify this, we should divide this by a GCF. I'm thinking 5 here. If we go ahead and divide these both by 5, we can see if these numbers are relatively prime. It looks like 7 and 8 are relatively prime. So this would be the fraction version of this ratio, or this comparison of 35 out of 40 points. That means you get 7 out of 8 points proportionally. Now to get the decimal here, what are we going to do? Well, 7 over 8 is the same thing as 7 divided by 8. So you can go ahead and write 7 divided by 8, and you can do it by hand or you can use a calculator, but that's going to be 0.875. So that would be our decimal. That would just be 0.875, or you can read that as 875 thousandths. That would be the decimal. Now, if you want to take this decimal and turn it into a percentage, then take this 0.875 and multiply by 100. That will go ahead and turn it into a percent. So we're going to go ahead and slide that twice to the right, and you're going to see that's going to be 87.5%. And so the percentage version of this is going to be 87.5 or 87.5%. So just like that, we will have our percentage. All right, what if we made 50 out of 75 free throws in a season? So the original comparison here is 50 per 75. That's our original fraction here. Let's go ahead and see if we can simplify this. I think we can divide these both by, let's see, I think I'm gonna go by 25 here. I think that's their GCF. If you divide 50 by 25, I'm gonna get 2. And if we do 75 divided by 25, we're gonna get 3. And I don't think this can be simplified anymore, so this would be our most simplified fraction here. Now, how do you turn this into a decimal? Well, you can take 2 and divide that by 3. And you can do that again by hand or type it into a calculator. That's going to be 0.6 repeater. So it's going to be 0.6666 forever. So our decimal is going to be 0.6 repeater. Now, what if we want to turn this decimal into a percentage? It might help just to write a few of these 6's out so you can see what that looks like. But to turn this into a percent, let's multiply it by 100. So if we do that, we slide this over 2 times to the right. And if we do that as well, it's going to be 66.6 repeater percent. So you can write this as 66.6 repeater percent, or you could also write it as 66 2/3%. So either way is okay, up to you, but the directions don't say to write in a specific way. So that's fine if you want to write it as a decimal percent or a fraction percent. For this last one here, we get 80 out of 75 points on a science quiz. So let's go ahead and see that's going to be an improper fraction. So you must have gotten over 100% here. So 80 out of 75. Ask yourself, can you find a GCF here other than 1? I think we can divide these both by 5. And if we do that, we would get 16 over 15. And so this would be the most simplified fraction here. If you wanted to, you could write this as a mixed number and write 1 and 1/15. That also lets us know immediately that it's going to be over 100% or more than 1 as a decimal. And now if you want to find the decimal, what we can do is use the improper fraction. That's a little bit more helpful. So 16 divided by 15. And you can go ahead and divide that by hand, or you can divide that in a calculator. You should get 1.06 repeater. And that lets us know that our decimal is 1.06 repeater. Okay. Now, just like earlier, how do you turn a decimal into a percentage? Well, you can write your decimal 1.06. Again, if it helps to write a few more 6's out, it might make it more clear. We're going to multiply this by 100 to turn it into a percent. So if you do that, you will slide it twice to the right here. And so if we do that, we're going to have 106.6 repeater percent. So that would be the percent here, 106.6 repeater percent. All right, cool. So these would be each of the fractions, decimals, and percent representations for each of these scenarios. All right, let's check out number 3. For number 3, we're going to go ahead and set up these percent proportions. So it's up to you what you how you think about this, but we have part to whole, or we have this is over of, or percent over 100. So as long as we set up a proportion to start, you can solve it however you may like, but I'm going to go ahead and do it in some different strategies each time here. So for A here, first thing I'm going to do is if we're told we have to set up a proportion, that means we have to have a fraction equal to a fraction or a ratio equal to a ratio. We're told that we have this 160%, so percents are per 100, so I'm just going to go ahead and put 160 over 100. And they tell us that we have this is 36, so for this is 36, I know that that's going to go on top. How we know that is we see the is on top, and so the is going to go right with that value. Now the of here is going to be something we don't know. So when it says of what number, we don't know that necessarily. So we're going to go ahead and put that on the bottom. And that hopefully makes sense because of is on the bottom here. Next, there are a few different strategies you can go ahead and try to solve this. I do think sometimes simplifying these fractions can be super helpful. So if you wanted to simplify this, you could divide these both by 10 on the right. And you can also divide this right side by 2 and by 2. And if you did that, your proportion would be 36 to x is equal to 8 to 5. All right, and you can use this to help you, or you can just use cross multiplication here. It's kind of up to you, but if you multiply these diagonals, x times 8, that's just going to be 8x. And then if you multiply 36 times 5, that is going to be 180. All right, and then if you go ahead and divide both sides by 8 here, we're going to end up with a decimal, I believe. So 8 divided by 8 is 1, so we have 1x. And then 180 divided by 8 is going to be 22.5. Okay, so how are we going to write our conclusion here? We just found out that 160% of what number? Well, the number we found out is 22.5. So 160% of this number is going to be 36. All right, that would be our solution here. All right, again, there's more than one way to do these problems, so keep that in mind, right? That's just one way to do it. Feel free to do some other strategies as well. For letter B, to set up our proportion, let's just go ahead and set up a fraction equals a fraction. We have a percentage in here, so we have 45%. I'm gonna go ahead and put that over 100 right away. And then it says of 200. The of 200, number of is gonna go on the bottom, so I'm gonna put 200 down here. And then they say what is, so we don't know what the is part is. So we're gonna go ahead and put x on top here, right? Now everyone has some different strategies. Again, you can use cross multiplication or cross products and use some different strategies. But if I notice right away that 100 times 2 gets you 200, then we can just say that 45 times 2 would just get us what x is here. So in my mind, this is probably the fastest way to do this. So I could just say that x is gonna be 45 times 2. Or that's also known as 90. So writing our statement here, it says what is 45% of 200? We're saying 90 is going to be 45% of 200. And hopefully that makes sense, just because 50% of 200 would be 100. So 90 is a little less than 100, a little less than half. So 45% is a little less than half. So I personally wouldn't use cross products in this one because it's a little faster just to use equivalent ratios. For C, it says what percent of 80 is 48. So again, I'm going to put 100 on the bottom here. It does say what percent. So if we don't know the percent, then we're going to put X here. In terms of the is, it looks like it says is 48. So the is on top. And then it says of 80. So that of 80, we're going to put that 80 on the bottom here. Okay. Now you can go straight into cross products, but if I just focus on this fraction here, I notice that I can divide top and bottom by, maybe I can divide them both by 8, or I could even divide them by 16, but I'm going to do 8 just because I think we're going to get a nice number on the bottom that'll help us out here. So 48 divided by 8 is 6, 80 divided by 8 is 10. So if we have 6 to 10 is equal to X to 100, then I don't need to do anything else here besides just say that, oh, 10 times 10 is going to be 100, and then 6 times 10 is going to be 60. So we can say here that X is going to equal 60. So if you use a different method, you can check it with that too. The question was what percent of 80 is 48? We're going to say 60%. So if you had 60% of $80, just say, that's going to be $48. So a little more than half of that 80 is 48. Okay, one more of these types of problems. It says what is 0.36% of 75? So that's smaller than 1%. To write our proportion here, I'm going to set up a fraction equals a fraction. Let's put 100 here. We have 0.36% or 36 hundredths of a percent. So 36 hundredths is going to go on top of 100. It does say of 75. Remember the of is going to go on the bottom. And then it does say what is. And so our unknown is going to be the part, and that's going to be X here. With these decimals, I wouldn't really mess around with these too much from the beginning. I would just multiply diagonals and save myself some time. So 100 times X is 100X. And if you multiply this 75 times 0.36, that's, I'm just going to write it out as 75 times 0.36. Now what is that going to be? Well, 75 times 0.36. You can use a calculator or do it by hand, but I'm going to say that's 100x is equal to 27, and then you can go ahead and divide both sides by 100. If we do that, 100 divided by 100 is 1, so we have 1x or x equals, and then 27 divided by 100 is going to be 0.27. So it says, what is 0.36% of 75? And we're going to say 27 hundredths is going to be 36 hundredths of a percent of 75. So it's a very small amount relative to that 75. And that makes sense just because it's less than 1%. It's a little more than 1/3 of a percent. All right, for number 4, we have to go ahead and sketch some double number lines to represent these scenarios. Then we're going to go ahead and solve, but feel free to do however you want after you create your double number line. So for A here, it looks like I'm just going to start off by drawing these 2 number lines just like this. And what are the 2 things we have? Well, percentages are always going to be part of our double number lines. And then in this particular problem, we're talking about questions at trivia. So we're going to put questions over here. It looks like Rabab was playing a trivia game, got 80% of the questions correct. So 100% would be over here. That's all the questions. And 80% is what she got out of it. So put the smaller number to the left and the bigger number to the right. If she got 56 questions correct, how many total questions were there? Well, when they say how many total questions, we don't know the total, but we do know the 80% she got was 56 questions. At this point, you're just going to go ahead and solve it however you'd like to. But you can say this 56 over x is equal to 80 over 100. That's probably how a lot of people are going to set these types of problems up. So you can say 56 over x is equal to 80 over 100. Now, personally, what would I do? I would divide top and bottom by 10 here. So what I would have 56 over x is just equal to 8 over 10. And the reason why I just wanted to start by doing that is I noticed that 8 times 7 is going to be 56 if I go from the right to the left. So 10 times 7 would tell us what x is here. So in this case, that would be 70. So you could say that there were a total of 70 questions. This would be a good way to kind of summarize what we just found out. And that makes sense because if she got 56 of them, 56 out of 70, if you divide those as 0.8, which is 80%. All right, for B, I'm just gonna go ahead and set up a double number line. And it looks like we're gonna have percentage as one of them. Oscar is playing a video game, so we're talking about levels here. So I'm just gonna go ahead and label this other number line as levels. He beat 36% of this game, so 36% is not the entire game. That's over here on the left. 100%, I'm gonna put this over here to the right. It says there are 150 total levels, so to beat the game, you have to beat 150 of them. That's the entire game. How many has he beaten? Well, that must be the part here. So we can set this up as x over 150 if you'd like, and that's gonna be equal to 36 over 100. All right, so I think for me, what I'm gonna do is I prefer just to divide this by 4 and divide this by 4, just to simplify the ratio to the right. So this is gonna be x to 150 is gonna be equal to 9 to 25. And then I'm gonna notice here that 25 multiplied by 6 gets you 150, and then 9 multiplied by 6 is going to be x. So 9 times 6 is gonna be 54, so I'm gonna say x equals 54. So putting this together, if he beat 36% of the game, he must have beaten 54 levels, so we can say Oscar has beaten 54 levels. So he's 36% of the way through beating this game. If it had 150 total levels, he's at level 54 right now, or he's beaten level 54. All right, let's check out C. For C, Hannah has said hello to 48 people that she passed in the hallways. So let's see, we're saying hello to people, which is always nice. We go ahead and set up our double number line here. One of these rows is gonna be the percent, and then we're gonna say, I don't know, we'll just say hello here, or greetings. It says what percent, so the maximum percent is she could say hello to everybody, that's 100%. They say what percent, so that's gonna be X over here. All the people she passed was 60, that's 100%, and she said hello to 48 of them, so that's gonna be part of that. Okay, so there's our double number line. And we can set this up as 48 over 60, so 48 out of 60 people she said hello to, and that's some percentage out of 100. Okay. I think what I'm going to do is divide this by 6 and divide this by 6 because I can get a nice number that will go into 100. So I'm going to say this is going to be 8 to 10 is equal to x to 100. Now, the reason why I did 6 specifically because I noticed that 10 times 10 would be 100. So if we do 8 times 10, that will be 80. So x would be a total of 80. So you can say that Hannah said hello to 80% of the people. All right, so that's pretty good. She said hello to 80% would be 4/5, so she said hello to 4/5 of the people that she passed by. All right, one last type of these questions. So I'm gonna go ahead and just set up 2 number lines here. So here is one and here is the other. And it looks like we have percent as one of our number lines, and then we have a tip, or we have the amount of money that we're talking about spending here. So 100% of the bill would be all of the money, but she's leaving a 25% tip. That's a little bit on the generous side maybe. And then the total bill was $64.80 or 64.8. We're trying to figure out how much money she's leaving the waiter or waitress here, right? So our ratio is some amount of tip out of the bill of $64.80 is equal to 25 out of 100 here. Okay, so 25 out of 100, you can just simplify this, divide this by 25 and divide this by 25, all right? Just deal with some smaller numbers here. So we're gonna have x over 64.8 is equal to 1 to 4. And this one's not too bad. I think 64.8 divided by 4 is gonna be a nice number. So if you do 64.8 divided by 4, it's gonna be 16.2. So if you multiply 4 times 16.2, just use a calculator if you want, then you should multiply the top by 16.2 also. So if you do that, you're gonna get x would be equal to 16.2. So you can say she left a $16.20 tip. All right, that's what that 16.2 represents. And that is 25% of what all the food costs. So that is a nice little tip there. All right, moving on to number 5, a survey conducted where 450 students responded what their favorite sport was. So we have all this information. They did miss a little bit of information here, so notice that for baseball, they kind of lost this percentage here, but we can figure that out in just a little bit. We'll just take care of the other problems first. So in the first question here, it says, to the nearest whole person, how many students chose soccer as their favorite sport? Well, for soccer, how would I do this? Well, how many, we can say 18% of how many people chose soccer. Well, 18% of the 450 people chose soccer. Another way you can write this is 0.18 of means multiplication. So you can do 0.18 times this 450. And if you take 0.18 times 450, you're going to find out that's going to be 81. So you can say 81 students or people chose soccer as their favorite sport. If you wanted to set up a proportion, feel free to do so, but to me, this would be a quickest way of solving this type of problem. For letter B, it says here, to the nearest whole person, how many students chose tennis? Let's take a look here. For tennis, we have 26%. So how many total people we have? We have 26% of everybody. So of the 450 people, 26% is 0.26 of means multiplication. So you're going to multiply here. So we have 0.26. You could type this into a calculator. Multiplied by 450 is going to be 117. So we know that 117 students here preferred tennis. Okay, so that would be how many students, and this should be more than the amount of students that preferred soccer just because the percentage was higher. For letter C, it says, to the nearest whole person, how many people, students chose baseball? So baseball is interesting here. So everything here, all the percentages should add up to 100%, right? 100% total. So one of these is missing here. So if we take the 100% and we minus the 26% and minus the 15%, minus the 18%, minus the 20% and minus the 5%, or all the other sports here, we're going to find out that this right here, the missing data, is going to be 16% of the people chose baseball. Okay, so even though they lost that piece of paper, you can figure out what that number is going to be by making sure that all of these numbers here, if you add them up, they have to add up to 100%. All right, so 16% of the people chose baseball. So I'm going to go ahead and write that as 16% of everybody chose baseball. So that's of the 450. So that's going to be 0.16 or 16 hundredths multiplied by 450. And if we go ahead and multiply 0.16 or 16 hundredths by that 450, we're going to find that we're going to get 72. So 72 students are choosing baseball. All right, so a little extra step in that one, but not too bad, hopefully, if we know percentages are out of 100. For D, to the nearest whole person, how many more students prefer tennis over basketball? So for tennis, we already know how many students like that one. So tennis equals 117. And you could sit there and figure out the basketball and figure out what that number is going to be. And then you could go ahead and subtract it. But there's another way you could do it too, which I'm going to do. So for tennis and basketball, if we compare their percentages, we have 26% and we have 15%. There looks like there would be a 11% difference between these two. And so if there's an 11% difference, we could find 11% of everybody, and that would be roughly the number of people that liked tennis over basketball here. So what I'm going to do here is find 11% of the 450. And again, feel free to do this another way if you'd like to, but this will be 0.11 times 450. And if I do that, 0.11 times 450 on a calculator, it's going to be about 49.5. So I think if you find out the number of basketball students and subtract, you're going to get that's around 49 or 50 here. So to the nearest person, we're going to say 50 students. About 50 students more prefer tennis over basketball. So if you got about 49, that also is going to be okay if you ended up figuring out the number of basketball students. So basketball, if I figure that actually, let's just do that right now, it's 15%. So I'm not going to write it, but if I do 0.15 times 450, that's 67.5. So we would actually round that to, put a squiggly equal sign here, we would round that to 68. Okay, just because 67.5 is going to round to 68, or maybe I'll write that. I'll say it's equal to 67.5. But if you have to round to the nearest person, we would round that to 68. And then so if you do 117 minus 68, that's going to be 49. So if you ended up putting 49 here, that would also be okay. All right, depends on how you did it. If you went with the 11% because you went with the percent difference first, or if you figured out the numbers and rounded later. All right, let's talk about going out to eat. Let's talk about some food and tax and tip and total cost. So the total food here is $43.12. If we want to find tax, that's going to be 7% of this 43.12. 7% is 0.07. Of means multiply, so if we multiply here, it's going to be 0.07. I'm going to type this in a calculator, times 43.12. That's going to be 3.0184. And when we're rounding here, we go to the hundredths place, so underline the hundredths place. The thousandths place of 8 is going to tell that 1 to bump up here. So we're going to say this is going to be about $3.02 here. For tip, we have 20% of the food, so that's 20% of 43.12. 20% as a decimal is 0.2. Of means we're multiplying, so it's multiplied by 43.12. In a calculator, 0.2 times 43.12 is going to be 8.624. And rounding this is the hundredths place, this 2. This 4 is gonna instruct this 2 here to just stay the same. Like don't change because it's 4 or lower. So let's stay at the bottom here. So it's gonna be $8.62. Now to get the total cost here, there was one way you could do it. You could just add up these 3 values, or you can also just take the percentage and multiply the decimal version of it by the food cost. So 127% of this would be 1.27 times this 43.12. And if we go ahead and take that and type into a calculator, 1.27 times 43.12, that's going to be 54.7624. And pennies are going to be at the 6 and hundredths place. The 2 and the thousandths is going to tell the 6 to stay the same. So the total cost here is going to be $54.76. So give or take a penny, that should be correct. Even if you added these, it should be very close to this value over here. All right, let's try a couple more practice problems with these. So once you do a couple, hopefully you get the hang of it. The food bill here, when you go to Nomad Pizza, is going to be $54.19. Tax is going to be 7%, so we're going to find 7% of this 54.19. I'm just going to actually write this in. This will be 20% of the $54.19. This will be 127% of the $54.19. Maybe I'll just rewrite these all together. So 7% is 0.07. Of means we're going to multiply by the food. 20% is 0.2 as a decimal, so 0.2 times 54.19. And 127% as a decimal is 1.27. And we're going to multiply that by $54.19. So 0.07 times 54.19, that's going to be 3.7933. And then I'll just do all the calculations now. So 0.2 times 54.19 is going to be 10.838. And then finally 1.27 multiplied by 54.19 is going to be 68.8213. So let's go to the hundredths place each time. So the 3 is telling the 9, you can just stay. So that's going to be $3.79 for tax. For the tip, we have this 8 telling this 3 to bump up here. So this is going to be a tip of $10.84. And then for the total cost here, the pennies place is this 2, and the 1 is going to tell the 2 to just stay the same. So this total cost is going to be $68.82. All right, one more food related question. This time we're going to taqueria. We know the total food here is going to be $75.28. And let's kind of just repeat the same process here. So if you want to go ahead and try it on your own, feel free to make sure you can do this, but it's 7% of 75.28. Then it's 20% of 75.28. And you can find the total by doing 127% of 75.28. As decimals, this is 0.07. As a decimal, this is 0.2 multiplied by 7528. And as a decimal, this is 1.27 multiplied by 7528. So 7%, 0.07 times 7528, that's going to be 5.2696. For 20%, that's 0.2 times 75.28. That's going to be about 15.056. And finally, 1.27 times 7528 is going to be 95.6056. So if we round here to the hundredths place, this 9 is going to tell this 6 to bump up. So tax here is going to be about $5.27. For the tip, this 6 is going to tell this 5 to bump up. So this is going to be about $15.06. And then for the total cost here, we're going to say this 5 is going to tell this 0 to bump up. So we should have $95.61. All right. Here is one final question. In this particular one, we're going to say Mr. Lee opens up a bag of Sour Patch Kids, his favorite candy, and he counts out the following numbers of each flavor. My rule of thumb here is just going to be you should figure out how many total pieces of candy there are here. So 11 plus 16 plus 14 plus 18 plus 16. We have a total. I would just write this down right away for the beginning so you know. The total is going to be 75 pieces of candy here. And so if we want to go ahead and say how many are going to be cherry. So for cherry here, let's see, the only one we really care about is this one, that's 18. So it's going to be 18 out of the 75 Sour Patch Kids here are cherry. We should go ahead and see if we can simplify this. So I think using our divisibility rules or our ladder method, whichever one you want to use, we can divide these both by 3. And if you do that, we're going to end up with saying this is going to be 6 over 6 over 25. I think that's right. Yeah. So I think these are relatively prime, the 6 and 25. So that would be our most simplified fraction. Now, if you want to go ahead and turn this into a decimal, actually, I'm not even going to do any division or anything. I'm just going to multiply these both by 4. So if I do that, that's going to be 24 hundredths. And you may say, well, why make it bigger? Well, if you have 24 hundredths, then I know right away that the decimal is going to be 24 hundredths. And once we know that, then you can slide the decimal over 2 times, or you can see that this is per 100, so this must be 24%. All right, so there you have 7 different practice problems, breaking down some different aspects of percentages and comparisons, linking our ideas of ratios and proportions and comparisons of comparing values per different amounts. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work, and I'll see you in the next one.